Okay, so what do we do? Tell me, teach me. What do we do here? What do you think?
Solve each side and add.
What do you mean solve each side? Pick your words carefully. Tell me. I think you're saying you're thinking the right thing. But choose your words. Everybody close up Chromebooks. What are we gonna do? It does, the parentheses, how come they're there? What are they? What purpose are they serving? What is it? To separate the two complex numbers, right? Each of these complex numbers is written in standard form for a complex number, right? Written in the form a plus bi. What do we call a?
A real number.
The real part of the complex number. What's b? Imaginary part. So what's the real part of the first complex number? Imaginary part? 14. Second complex number, real part? Imaginary part? 2. Okay. So then those parentheses really are just there to collect the two parts of each complex number. That's what they're doing for us. That's how they're helping us organizationally. Do they do anything mathematically? No. They don't need to be there, do they? How come? We can just get rid of them. How come?
Which ones?
The both of the sets of parentheses, the grouping symbols. They're organizing something for us, but are they mathematically necessary?
No.
Yes.
You're right. How come?
Only keeping
Keeping the, okay,
Yeah.
true. Now, that's different than, like, let's take another example. Like if I did something like, I'm going to use x's this time, just because all I'm worried about is just the patterns, not the complex number part for a second. If I add up x plus 4 plus x minus 7, I don't need the grouping symbols, do I? They're not doing, I can just get rid of them freely, right? What if I do this?
And then you need the deal, because you have to dispose of that. I just
Okay, in this case, in order to get rid of them, I can't just erase them. I would have to distribute first, right? In the second example, the grouping symbols are doing something mathematically. They're necessary because I've got two factors that are being multiplied. There's something to distribute, right? But up here, there's nothing to distribute other than 1, and multiplying by 1 doesn't change anything, right? Same thing up here, right? There's nothing outside of the parentheses that's being multiplied other than 1. So I can just get rid of them. You see my point? Okay? So then, if that's the case, let's do that. They were useful in breaking and separating the two complex numbers, but when I want to add this up and get one big complex number, let's just get rid of the parentheses. Plus negative 4. What's plus negative 4? Minus 4, okay. Okay, now what do you think I do?
add like terms. Yeah.
Add like terms. Yeah, I'm just going to combine the two real parts, right? Does that make sense? So negative 7 plus negative 4 is 14i plus 2i is
16i.
Yeah, you just treat that I like a variable, don't you? Treat it just like an x. That's it. It's no big deal, right? Okay, couldn't be easier. Okay, try that guy. What's the answer going to be here? I can just ignore the parentheses again, can't I? Right? They're not really serving any purpose. So what's the sum of the real parts this time? Negative 3. There's only one real part, isn't there? Okay, what about the imaginary parts? Okay, negative 13 plus 5 is negative 8.
Oh, that really hurts.
Okay, try this guy. Okay, Trent, what's going to be the real part of the sum?
11.
11. Wyatt, what's going to be the real part?
0.
0. Yeah, plus 0i. Is that how we write it?
No.
We don't need to, do we?
Just
You-
11?
Just 11. Yeah, right. 0 times I is 0. We don't say that because you never have in the millions of times you've said numbers in the past. You've never said, like if I ask you, ask me how many pieces of candy you got. Oh, I have 7 plus 0 items. That doesn't make sense. You wouldn't say that, would you? You just say 7, right? We know if the imaginary part is 0, it just makes it a real number, right? So the answer would just be 11. Okay. All right. How about this? Okay, what's the difference there? We're subtracting. Okay. So what do we have to do? I have to say a little louder.
That negative will become positive.
Okay. Oh, good. Okay, good. So we've got to, now this time, we got to be careful just getting rid of the parentheses. The first set of parentheses aren't doing anything, but the second set are, right?
You're
The
distributing
second
negative
set,
one.
what am I distributing over the second set?
Negative 1.
Negative 1. Good, right? So I've got to, when I get rid of the parentheses on this one, bless you,
Thank you.
Bless you.
I get that, but now when I distribute, those, what happens? I get a +1 and now it's just an addition problem like before. Okay, no big deal, right? Okay, so there's adding and subtracting. Last issue, multiplying. Okay. Before we do this, let's have just a little quick review from yesterday or something. So if we know that the definition of I is what? What's the definition of the imaginary unit I?
It's an imaginary.
True, but what's it equal to?
No,
Well, it equals
negative.
itself.
1
What's it equal? Almost, not negative 1, but the
1/3.
square root is negative 1. There you go. Good.
Oh, that's.
There's the definition of I, right? The square root of negative 1. Okay? So let's go through our little list here then. I to the 1 just equals I, which is the square root of negative 1. What's I squared? Negative 1. Because if I square a square root, it erases the radical, right? What's I cubed? Negative I, right? Product of I squared times I is I cubed, right? So negative 1 times I is negative I, and I to the 4th?
1.
1. I squared times I squared. Negative 1 times negative 1 is positive 1. What's I to the 5th? I. Good, because now when we get to the
Start
next round, we just start over, don't we? Right? We're just going to cycle through those 4 values forever. So what's I to the 96th?
I.
No. Oh, yeah, no.
Positive 1.
What's I to the 96th?
96.
Negative I. That's it.
I.
One.
1. How'd you get that?
I said 1 first off.
You did?
Said positive.
Well, you said so much.
Because
We
you
just
go
got all-
in groups of 4.
What's that?
You go in groups of 4.
You go in groups of 4. 4 goes into 96 evenly, doesn't
That's
it?
what I was thinking.
24 times, okay? So if I to the 96 is 1, what's I to the 98th?
Negative 1.
Negative 1, right? Good, because 96 takes us to there. The next one loops back up to the beginning, right? So there's 96, 97, 98, right? And the way we could get that quickly is we could just say 98 divided by 4 equals something with a remainder of 2. That's what we care about, because that means we're going to be on the second row of this cycle, right? See what I'm saying? This is a 24, but who cares? We don't care how many cycles we go through. All we care about is which row of those 4 we end up on, right? To get our answer. Okay, make sense? Okay. So now let's do this problem. What are you going to do? We said treat I like a variable. What would you do if those were x's instead of i's?
Combine like terms.
Well, maybe eventually, but how do you multiply binomials like that? What do you do? You FOIL, you could FOIL, if you remember that. FOIL is really just another name for what?
Multiply.
Yeah, but I mean, what do you do if you have multiple terms like this and you're multiplying? What do? You distribute, sure. Okay, so we could distribute the negative 9. Negative 9 times 7 is what? Negative 63. Negative 9 times negative 11i is 99i, right? Because we just multiplied and treat it like a variable.
Oh, that's the rainbow thing.
What's that?
Rainbow, no?
Yeah, it's right, like a rainbow. So now what about the negative 8i, right? I'm going to distribute that. Negative 8i times 7 is
56i.
positive or negative?
Negative, negative.
And then negative 8i times negative 11i is
Positive 88i.
positive 88 I squared.
Oh, because there's 2 of them.
Okay. What is I squared equal to? Negative 1, right? So every time when you're multiplying out expressions involving I, so complex numbers, every time you do that, when you get an I squared, you always remember that I squared equals negative 1, right? So this last term, what happens to this last term then? It becomes 88 times negative 1, which is what?
Negative 80.
Ah, okay. So we can take a shortcut. Anytime we have an I squared that's part of a term, when we multiply something out, what does that I squared really just end up doing?
Making that negative, like,
Yeah, it's just changing the sign, isn't it? Right? Does that make sense? From positive to negative. I mean, if it had started off negative, what would it end up? Positive. Yeah, it's just changing the sign, isn't it? Right? And so then if we add all this stuff up, what do we get? We'll just combine like terms. So I've got the terms without i's. Those are the parts that are going to contribute to the real part of our answer, right? So negative 63 and negative 88 is what?
negative,
Negative
15.
40.
5.
Well, what's 60 and 80 is what?
140.
140 plus 3 and 8 is,
11.
there you go, 11. 140 plus 11 is 151, and it's negative, isn't it? So negative 151. And then what about the I terms? We got positive 99i minus 56i.
189i.
What?
Oh, whoa. I thought I was looking at the 88. 155.
43, there we go, right? Because
Oh,
we got a
it's
big
negative.
positive and a small negative, so 43i. There's our answer. Good?
easy,
Easy. No big deal.
like,
Go, you can practice. There's a little assignment up you can work on.
I was gonna snap. She said no.